On May 20th, 2024, Microsoft released a new feature for Copilot Plus called Recall. Now, I'm sure you've read all about it and heard everyone protesting this new feature, as it definitely was not implemented securely. It takes screenshots every couple seconds and has image stores of all those screenshots and OCRs them and puts all this data into a database that's not even encrypted on the system. So an info stealer could get in there and easily just soup up that data. Now I'm going to try not to just beat a dead horse and continue to do all the things that everyone's done talking about this threat or this feature. Sorry, not threat. I really want to focus on detections. Let's see what we can do if someone is to abuse this feature and try and extract that data from our system. Is there a way for us to detect it? So one of the researchers that was early on in this area was Kevin Beaumont. He quickly got a PC that could run Copilot and started digging into it and wrote a pretty big, nice write-up about it. He's very active on Twitter, and a lot of the community was. And luckily, because of people like Kevin, Microsoft pulled this feature back and started reassessing the security and trying to make it a bit better. So I highly suggest reading this article, but again, this has been talked about in a lot of YouTube videos, a lot of articles. I really want to focus more on detection. So quickly, one of the things that I used to try and understand this a little bit better from a logging perspective is I utilize this tool called Total Recall. Basically what Total Recall does is I can just run it. It's a Python script, and it goes, changes the permissions on the recall folder or directory, and basically grabs all that data out of there, puts it into its own location, and extracts information from that data. So this is a good example of a really easy way to just steal the data from the system and export it, exfil it. Doesn't exfil, but you get the idea. So I put together a session here, and this session essentially is just, again, running recall. So you can see here, I run Total Recall, it finds it, modifies the permissions, and then extracts the data. And so there's a few things that we can detect here, a couple of different detection opportunities that I want to go through. So first off, we have the Total Recall execution. We can't, that's just a Python script executing. There's not much to go off of here, but permissions being changed in this specific instance using iCackles, this is something definitely, right? This can be detected, and there's even a good Sigma community rule for it. And we'll dip into that real quick, and then we'll go on to the next detections here, which are going to be specifically the process accessing the recall database and accessing the recall image store directory. And so for those two detections, you will have to set up object access auditing for that specific folder. And I'll kind of get into that later, showing you how to enable that feature. So for this first log, we're going to look at iCackles being spawned by Python. And it's specifically being spawned to change the permissions on the UKP directory, which is the directory that stores the database and has the folder with the images in it and whatnot for recall. It grants the current user full access to that directory so that it can then start slurping up that data. So for a detection opportunity here, again, this is a Sigma community detection. It's basically looking for a bunch of different tools that could be used to basically change the permissions on different directories and files and whatnot. So this is a really good option. It might be a little noisy because it's not specific, but it is good to be able to easily hunt for or find that type of information if you need it. You could definitely clone this and create a more specific version that's only looking at that directory path. And obviously that would be a lot less noisy, but this is a good catch-all from the Sigma community that can be utilized to detect this type of permission changing activity. Now the next ones, like we said, we're looking into process accessing the database and the image store for recall. So in this first log, you can see Python is trying to access the UKG database, which is the recall database that stores tons of information about all those screenshots and activity that you've done on your computer. And the second one here is Python trying to access the image store, which is the folder that is actually holding all of the screenshots that recall has ever taken. And so you can imagine, right, if the database in that folder of images gets pulled and OCR'd, that's not good. The initial implementation of recall was not filtering anything, right? It was slurping everything up. Like, it wasn't trying to hide passwords or any sensitive information in these things. It was pulling it all. So this is an attacker's dream, right? If you're writing a stealer and you have to manually like figure out how to extract things from different areas of the computer, and now Microsoft just put it all in one place for you that you can easily just grab, that's going to make their job so much easier. So not great. Hopefully this gets improved with the next release. So detection wise on this one, we have the opportunity here to enable, like I was saying, the event ID 4663, which shows us, again, if we go back here, it shows us the attempt was made to access an object. And so you enable this, and then you specify on that directory that you want it to be monitored. And again, I'll put up a quick example of how to get that enabled towards the end. The access list 4416 is showing us that there was a successful access, right? This is saying there was an access that happened rather than an access just being requested. And then the object name obviously it's looking for any events that have to do with anything within that UKP directory. So this is an interesting one. We excluded process name AIX host and AI host because those are two processes that will access those legitimately. They're supposed to, but pretty much anything outside of that is probably suspicious. Now there may be something like search index or something else. I haven't noticed that yet in the research, but we'll keep an eye out if we find any other processes that do access that legitimately. We'll add them to the filter list. But for now, this is a pretty tight detection that should detect just processes that should not be accessing that database. You will notice it ran against the detection here. And if we go back, you'll see, right, tons of these process access. That's because it accessed every single image in that image store. And there was tons of images, right? So it is triggering for every single access in there. So this can be noisy if an attacker does do this and pull every image or every bit of information out of that directory. So just be aware of that. It could be, right, if you use Splunk or something, there could be some correlation options here to basically, or aggregation options here to filter this down to say like, hey, if it hits this many times, then trigger an alert. But this basically will show you anytime anything accesses something in those folders. Hopefully this was helpful. Definitely feel free to jump into our platform, make a community account. You can access these detections. As always, hit the like button, subscribe, let us know what we can do next time, and we'll see you again later.